The Siberian permafrost is releasing a Paleolithic sickness, posing a serious threat to the Earth. Allow me to tell you a riveting story set in a future that could be right around the corner. Our story begins with an astonishing find unearthed by a Russian scientific team in the far depths of northern Siberia's permafrost, the remains of a female mammoth preserved for an incredible 22,000 years in the icy embrace of Salik, a secluded mining settlement. As if rising temperatures weren't enough to defrost the frozen ground, the industrial complex's excavation and drilling would disturb this majestic creature's perpetual slumber. This superbly preserved mammoth had sadly died during delivery on an unknown spring day, as revealed by analyzing its stomach contents. A huge group of mine personnel and technicians would be present among the expedition members to see the recovery attempt. Many of them would help with the excavation, maybe without taking the appropriate safeguards, touching, pushing, and tugging with their bare hands. Accidents would inevitably occur, and their blood would come into contact with the fluids leaking from the thawing carcass. These fluids were polluted with spores of microbes that were common in the Paleolithic era but are completely foreign to our immune systems. Enter Patient Zero, a technician who immediately after the mammoth's exhumation would board the corporate bus to the nearby Yakutsk airport, hoping to fly to his family in Novosibirsk, a Siberian city of 2 million people. He began sneezing and coughing during the bus ride and the ensuing crowded commercial flight. By the time he arrived at his destination that evening, he would have met at least 100 additional people. If he felt ill throughout the night, he would seek medical attention at the nearest hospital in the morning. Unfortunately, after only 3 days, Patient Zero would die horrifyingly in front of many befuddled and powerless doctors. As you might imagine, the aftermath would be all too familiar: headlines, worrisome reports on the contagion's symptoms, a frantic race against time for scientists to find an effective vaccine, denial giving way to abject fear, and eventually, an apocalypse. No, this isn't the plot of a bad disaster film, it's just what could happen as soon as tomorrow. Let's have a look at why this is happening. Hello and welcome to Z. Follow us by subscribing the channel and ring the bell to stay updated. Global warming has long been linked to the establishment of new health concerns, owing to the spread of tropical illnesses to temperate regions such as Western Europe. However, we've lately learned that another menace may be lurking in the far north, where millennia-old bacteria could be freed by rapidly thawing Arctic Siberian permafrost. Permafrost. It's a term we've heard a lot over the years, thanks to reports of prehistoric animals completely preserved in Siberian ice. Permafrost covers about 15% of the northern hemisphere, some of it dating back millions of years. Explorations into the Arctic permafrost microbial flora began long before media interest peaked. Bacteria were discovered in Siberian permafrost as early as 1912, and by 1944, we knew that these bacteria could survive in such conditions. This study, predominantly undertaken by Russian scientists, was largely ignored by their Western counterparts for the majority of the 20th century due to the Cold War and language problems, with much of the Soviet researchers' work published in Russian journals not being communicated outside. The word permafrost, coined by American geologist and paleontologist Seaman Muller in 1943, refers to permanently frozen soil layers located several meters below the surface, particularly in high-latitude and high-altitude settings. Permafrost is a rich mixture of decomposing organic materials and a diverse population of microbes, making it perfect for preserving cellular structures and DNA. It's cold, dark, anoxic, and neutral, the polar opposite of the conditions that kill surface bacteria quickly: heat, UV light, oxygen, and severe pH levels. The lack of water below the active layer halts all metabolic activity, killing out most microorganisms. However, some of these creatures can enter a latent state known as cryptobiosis, which allows them to resurrect under certain conditions. This is true not only for single-celled microbes like bacteria or protozoa, but also for viruses, which do not require any metabolic activity to survive. As a result, deep permafrost becomes a permanent storehouse for ancient microbes and viruses dating back 1 million years. But it isn't all. Prehistoric bacteria and viruses are also released and reactivated as a result of thawing, some of which may still be contagious and resistant to modern antibiotics. Mummified carcasses of mammoths, reindeer, woolly rhinos, and even humans have been discovered in the oldest permafrost layers. Bacteria, viruses, and spores have been cryogenically preserved within their frozen bodies for centuries, if not millennia. Not all of them survive intact, but a small number of these species can tolerate freezing and can even reawaken and come back to life as a result of climatic change. It's not simply a theory. These species exist, have been identified, and have been properly researched. With a morbid sense of humor, scientists have dubbed them zombie viruses. So far, a dozen viruses have been identified that stretch back tens of thousands of years. The oldest, dating back 48,500 years, is a huge virus named Pandurovirus yedoma, which was discovered buried beneath a lake, while other viruses have been retrieved from other sources, including the fur of a mammoth and the guts of a Siberian wolf, both of which were encased in permafrost. When these viruses came into touch with single-celled organisms like amoebas in laboratory trials, they revealed their ability to infect them. As far as we know, no one has yet dared to experiment with human cells. But not only do ancient viruses live in permafrost, many more came from more recent epochs. A lung sample retrieved from a woman's body unearthed from permafrost in a town on Alaska's Seward Peninsula in 1997, for example, contains genetic material from the influenza strain responsible for the devastating 1918 epidemic that claimed 20 million lives worldwide. In 2012, genetic signs of the smallpox virus were discovered in mummified remains of a lady buried in Siberia 300 years ago, a disease we only managed to eliminate at the end of the past century. An even more concerning incident occurred during the 2016 anthrax outbreak in Siberia, which killed dozens of people and thousands of reindeer. It was triggered by the quick and deep thawing of permafrost during unusually warm summers, which allowed old Bacillus anthracis spores to re-emerge from ancient human burial sites or animal carcasses. Despite the discovery of antibiotic-resistant genes in permafrost, epidemiologists say we may reasonably anticipate ancient bacterial epidemics to be managed by current antibiotics. Antibiotics are broad-spectrum medications that are expected to be effective against diseases such as plague, anthrax, legionellosis, typhoid, tuberculosis, and salmonellosis. Antibiotics, on the other hand, target bacteria rather than viruses. This is where a cautious and pessimistic line of thought emerges, as recent pandemics have sadly demonstrated. Any novel virus, even if related to established families, nearly invariably necessitates extremely precise medical remedies, such as new antivirals or vaccines. There are no broad-spectrum antibiotics against viruses. As a result, it's reasonable to consider the possibility that ancient virus particles could remain infectious and reappear as a result of the thawing of ancient permafrost layers. Thawing permafrost thus exposes us to the risk of encountering diseases that have previously decimated a significant portion of the human population, with no guarantee that current vaccines, developed for epidemics no more than a century old, will be effective against older strains of viral diseases such as smallpox, pneumonia, meningitis, influenza, or even the common cold. The true danger in this situation is that humanity may come into contact with a virus that is not only ancient, but also so ancient that it is completely unknown to medical science and our immune system. This occurred in 1519, when Cortés and de Alvarado's Spanish soldiers arrived in Mexico. The Aztec Empire was brought down by a few hundred soldiers, not only because of weapons, but also because of diseases carried with them by the Spanish. The conquest of the Americas resulted in the most extensive biological warfare in history. Smallpox, measles, plague, influenza, salmonella, scarlet fever, and chickenpox were among the diseases brought to the New World by Europeans beginning with Columbus' second journey. After a half-century of damage, the death toll was enormous. Only 3 million people lived from an estimated population of 15 to 25 million, excluding South America, by 1550. What caused this devastation? It's really that simple. The diseases carried by the Spaniards were utterly unknown to the Amerindians' immune systems, proving to be lethal and highly contagious. It was a shortage of antibodies caused by the great geographic separation between Amerindians and Spaniards in that case. However, in the near future, the triggering cause could be viruses from distant epochs. The human immune system may be incapable of dealing with pathogens from the past. Our immune defense has slowly evolved as a result of our intimate contact with the environment in which we have evolved. If there is a virus hidden in permafrost that we haven't seen in thousands of years, our defenses may be ineffective. Is there anything we can do to avoid this pitfall? Certainly. The greatest choices for preventing biological hazards from escaping permafrost are to halt the thawing process and solve the current climate problem at its source. Scientific information spreads in an ever-changing globe, and research on these Siberian viruses is just the beginning of a long journey. Combating the reemergence of millennia-old bacteria necessitates ongoing attention and strategic planning. We can only hope to contain rising risks if we gain a deeper understanding of these ancient germs and take concerted worldwide action. The ultimate difficulty, then, is not only identifying these zombie viruses, but also determining how society reacts to this new reality. Scientific breakthroughs must be addressed with care and insight, as well as daring and commitment. Only then will we be able to defend our globe and future generations from the silent but lethal threats lurking beneath Siberian ice. The time has come to act. Alright everyone, here's where the video ends. Thanks for watching, and don't forget to like, share, and subscribe.